Hello, everyone. I'm back. I was here half an hour ago, but hi, everyone. My name is Rav. I'm the program manager at Reactor London, and welcome to another episode. Before we begin, please take a moment to read our code of conduct. We're all here to learn, so please be respectful of other people's views, understanding of differences, and please be kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Today is the third and final episode of Building and Working with Virtual Networks in Azure. And this episode will be led by our regional cloud advocates, Gwyn and Liam. And today they will be talking all about building and working with virtual networks in Azure. Sorry, securing a network with Bicep. That's the topic. Apologies. I'm now going to bring them up on the screen and they will take the lead. Hi, Liam. Hi, Gwyn.
Hello.
Sorry, I messed it up a little bit, but I'll hand it over to the experts now. I'm going to go off the screen.
Awesome.
Thank you.
Thank you very much. I just want to point out, we're not doing Bicep. We're going to be securing inside a virtual network within the portal today. Just want to put that one out there. But yeah, let's take it away, Gwyn.
That Bicep part is referring because since it's like a series, that was like the first part. So yes. That's just to clear up any confusion. But yeah, hi everyone. Welcome to episode 3 of this lovely series that we are unfortunately finishing today, but who knows if we might have future episodes. We're very much open to recommendations and such like that. But yes, episode 3, securing your Azure virtual networks. I'm here with my colleague Liam. And as far as the agenda, we're going to talk quick intro about the series, dive into what is security, how do we secure virtual network, ACLs versus security groups, load balancing, then demo, and then we got a recap. So very similar to the format that we've been following in the previous sessions. About us, I'm Gwyn, Microsoft Cloud Advocate based in New York, YouTuber, .NET engineer, and serverless enthusiast. And now we have Liam.
Hello, everybody. It is great to be back here. It's great to have you all on the stream again. Yeah, it's going to be amazing. 3 episodes. This has gone so quickly this month. But hey, my name's Liam Hampton. I'm a Microsoft regional cloud advocate based here in London. I work really closely with the Reactor team and, of course, Gwyn, being a direct colleague of mine. I'm an open source contributor. Prior to being an advocate, I was a software engineer writing lots and lots of Go and Node.js code, which is fantastic. I'm an also technical blogger, so I've written quite a few technical blogs online on Dev2 as well. Through that, I've become an IoT enthusiast, spoken at a bunch of conferences, and yeah, I'm a world traveler. I love getting around, hence why we do advocacy, right? It's global and it's amazing. So I'll hand it straight back over to you, Gwyn, and let's get into this.
Awesome. Yeah, so the way we're going to sort of handle this is similar to last session, I'll take care of like some theory and then we'll, talk and chat and whatever it is. And then we'll have a demo in the later half with Liam, because Liam is actually the networking expert here. But anyway, about the series, goals, understanding how virtual networks are built and utilized, a little bit of Bicep thrown in there too. And then of course, get hands-on and put what we've learned into practice, which is why we're dividing it into slides and demo part. This episode, we're just going to understand a couple of basic VNet security concepts and then understand some basic load balancing concepts as well. Episode 1, we covered how to build a virtual network. So the infrastructure and parts of the infrastructure that we're working with today, we built it out and we showcased it and deployed it within the first and second episode. And that was utilizing Bicep, which is an infrastructure as code tool. Episode 2, we did some deploying some actual applications and I guess web apps into our subnets and our virtual machines. And then today, we're securing this infrastructure. Yes, the Microsoft Cloud Skills Challenge that we released, I think it was at the first episode, like the beginning of the series. We've already got about 400 people participating, which is an insane number. So absolute thank you to everyone who's been doing that. We'll have links for y'all to continue doing that. Remember, we still have vouchers to give away. Still plenty of vouchers to give away. So do make sure to get on that and then earn some networking skills, some Bicep skills, and then potentially earn a voucher to go and get yourself certified. But yes, today we are on episode 3, securing your virtual network. And keep in mind that anything that we are doing here, you can do as well. If you are a student, head over to aka.ms/A4us. And if you're a professional, you can go to azure.microsoft.com/free. And here you'll be able to create either free accounts or student dedicated accounts and utilize those free credits to get hands-on and put into practice the things that we're teaching you or sharing with you today. All right, let's kick off the theory portion here. Let's talk a little bit about what is security. Liam has given us a very sweet, concise definition here. But essentially, security is the concept of preventing unwanted access to resources. And luckily, Azure has actually a very, very robust networking infrastructure. And that comes with a bunch of different ways on how to secure your network. And we're going to take a look at a couple of them. We're not going to look at all of them because security in itself is a specialty and a career on its own. And we could spend hours and hours and sessions and months just talking about all the different security features and things that you can implement. But we'll try to cover the basics so you'll leave with a overall general understanding of what you can do, right? So we've been working with VNets, virtual networks, this entire series. We understand VNet is sort of like a logical isolation of actual physical Azure servers. And having your infrastructure organized in a VNet is actually already a first step of securing, because that's a way of like knowing that, you know, the traffic that comes into your VNet is going to be not also exposed to other VNets, right? To like different customers and things like that. So that's already step one. Sort of like something that you have to do because every sort of resource, networking resources have to live within a VNet when it comes to Azure, right? But we have a couple of options here, or sort of best practices. The first one is like we have our top level like VNet, and then we can logically segment our VNet, so our address space, into subnets, which are slices or parts of a network. And in terms of when you think of segmenting your subnets, there's actually a couple things here to keep in mind. First, you want to define subnets broadly to ensure that you have flexibility for growth. You don't want to make like super specific, small, like just very little IP addresses in one subnet, because later on, what if you need to add to that, or what if you need to, I don't know, change things or whatever it might be? That doesn't make a lot of sense, right? So first off, you know, keep them broad. Next, don't assign allow rules with broad ranges. Like you don't want to assign like an allow rule from IP addresses like 0.0.0.0 to like 255 to, you know, et cetera, et cetera. Not a good practice, right? And finally, use network security groups, which we're going to talk a little bit more about in a couple of slides, to protect against unsolicited traffics into subnets. The reason network security groups are mentioned here is because they work on the subnet or the virtual machine or the network interface card level. But there are other things that we can utilize here. Next, we have adopt a zero trust approach, which essentially is your zero trust is, you know, back when I guess networking was, or people accessing a network was more based on location. Like if you wanted to access a network in, I don't know, your office, like you would have to be at your office for that to be allowed. But now with the concept of like remote work or having like offices in London and your HQ in New York or whatever it might be, this approach no longer works. So now we have zero trust, which is essentially saying like, oh, just trusting access via a location isn't enough. So the next step to that is you give conditional access to resources based on device, identity, assurance, network location, and more. So it's not just one thing, right? So base your conditional access on more than just the location of the person who's trying, or the device or the thing, the entity that is trying to access your network. And then also, with the zero trust approach, you have the concept of granting temporary permissions to perform privileged tasks, and once those permissions expires, well, those privileges are removed, right? So those are two things also to keep in mind there. Next, we have control routing behavior. So when you are working with subnets inside of a VNet, there are these things called system-defined routes, which are created for you by default, or sort of implemented by Azure by default. So that's why you have a virtual machine in one subnet, and then those can essentially, or resources can essentially talk across subnets because those routes are enabled. This could be a good thing if this is what you need, but if you need more fine control, which most scenarios usually do, you have these things called user-defined routes, and then you can go customize whatever it is that you need. But highly recommended to configure user-defined routes when you deploy a security appliance for a VNet, right? And of course, after that, we have use virtual network security appliances. And we know that network security groups and user-defined routing work on the transport and network OSI layer. Does everyone know all the OSI layers? Because I absolutely do not. I think Liam might, but I don't. But like when I was reading about all these kinds of things, I was like, how do people ever know all of these rules and things like that? But anyway, but if you need security on a higher level, you would consider something like virtual network security appliances, and that would include like WAFs or web application firewalls, gateways, routers, applications delivery controllers, which I've never heard before this, and more things, right? So it's more of so like what your scenario is, what you need to filter at what level. It's not like one recipe or one set of tools will fit absolutely everything. It's a case-by-case basis kind of thing, right? Alrighty, and then we have optimize uptime and performance. So if you have, I don't know, your network and it goes down, or the server that contains your databases goes down, and then you don't have access to your data, that is also a security threat, right? So that's when we have to start to think about, all right, so how do we optimize for uptime and performance? Well, a popular and effective method for enhancing availability and performance is load balancing. And we're going to actually do some of that in today's demo. And we'll talk a little bit more about different types of load balancers that Azure provides for us in a couple of slides as well. But keep in mind that security is not only about allowing or blocking, but it's also about optimizing performance and such. And then finally, we have disable Rdp access to virtual machines. We've been using this for demo purposes, but ideally you would want to utilize something like a VPN, not just, hey, have, Rdp and SSH ports open, because attackers can use brute force techniques to gain access to your virtual machines, right? So keep that in mind. For demo purposes, for perhaps really small development purposes, completely fine. But you do not want to let these things open for production level, right? Okay, ACLs versus security groups. This was a little bit confusing to get into because the way Azure talks about ACLs is if you come from a networking background, or perhaps you come from like an AWS background or something like that, or a different cloud, the terminology is, though they do the same, the terminology is a little different. The way they speak of things is a little different, right? So Network Access Control List, or NACL, or just ACL, is a firewall that sits on the VNet level, so virtual network level. And again, remember I was saying before, like, you'll have different things that sit on different levels, and depending on what you need, like you'll sort of put them together, right? And in Azure, this ACL is called a firewall, Azure Firewall Law. So all traffic entering or exiting these subnets is checked against the access control list, but traffic between instances within the same subnet do not pass through the ACL. For that, you'll have to use something else. Why is that? It's because ACLs, or firewalls, are in this case, are only used for traffic that leaves or comes back from the subnet, right? And then keep in mind that ACL rules are executed in a defined order. So as soon as traffic matches a rule, it'll go through that, right? It doesn't keep going. So keep that in mind too. Network security groups, which we've been mentioning. We haven't deployed a firewall in the previous episodes, but we've worked a lot with network security groups. But according to Azure, a network security group is a stateful packet inspection device, which is a fancy way of saying essentially a basic firewall that uses the 5-tuple approach. So you have, when you're defining these rules, you have source IP, source port, destination IP, destination port, and layer 4 protocol. And similar to ACLs, you allow or deny traffic to and from a single IP address, to and from multiple IP addresses, or to and from entire subnets or network interface cards, which are associated with virtual machines. Keep in mind, so network security groups will sit on the subnet level or on the virtual machine or NIC level. It's usually you don't want them associated with, you want them or like with the subnet or with the VM. You don't want them on both. To keep that in mind. Now you might think like, working with all these network security groups, you have like all these rules, and like it could become maybe overwhelming is not the right word. Maybe more like complicated, or I don't know, it's just like a lot. But you can simplify network security group rule management by defining application security groups, known as ASG. ASGs are like groups of VMs that sort of have a similar purpose or a similar application, and then you would grab your network security groups and you would apply all those rules to your ASG, right? So they're meant to work together. So, as your use case is, if it grows, whatever it might be, you'll have to like find what's best for you. And here we have an example diagram of what it looks like to have. So we have a firewall sitting outside of the subnet, and then we have like some peering going on here. You see we have network security groups sitting on the subnet level. We have one here, we have one here. We have some load balancing and all these things here. I'm a big fan of network diagrams. I don't always understand them, but I think they're pretty interesting to look at. But yeah, this is essentially a scenario where you could use something like, oh, they even have express route in here. So essentially your ACL's here. You got some network security groups on the subnet level, VMs and all that kind of stuff, right? Alrighty, cool. What do we have next here? Load balancing, yes. So remember I was talking about security is not just about allowing or denying traffic. It's also about making sure your things are available, because if you can't access information or resources that are critical to your infrastructure or to whatever you have going on, that could be a security issue, right? So load balancing refers to evenly distributing load or network traffic across a group of back-end resources or servers or virtual machines, right? Fancy way of saying virtual machines. And then we have Azure load balancers, which operate at layer 4 of the OSI model, right? We have two types of Azure load balancers. We have a public load balancer that can provide outbound connections for virtual machines inside of your virtual network. And then we have internal or private load balancers, which are used where private RPs are needed at the front end only. And again, this is depending on what your use case is, right? So we have here another diagram, and Liam actually told me that we're going to be using somewhat of a similar infrastructure in today's demo. So excited. But yeah, we have a couple of web tier subnets. So essentially our front end or our web applications would live on these VMs. We have a public load balancer that will distribute traffic to either one of these three. And then we have an internal load balancer which has the business tier, which could be like the back end, could be like data, could be a bunch of these things, right? So you would utilize, it's not either or, you can use them in like combination or whatever it is that you need to, right? But public load balancers for what's coming in from the internet and then distributing whatever needs to get distributed within your subnets or to your back end would be your internal load balancing, right? Cool. And then finally, we have Azure Application Gateway, which is another type of load balancing, right? But Application Gateway can make routing decisions based on additional attributes of an HTTP request. So we're talking a different layer on the OSI model, right? For example, URI path or host headers, and this type of routing is known as application layer, OSI layer 7 load balancing. And then Azure Application Gateway can do URL-based routing and more. So if you need, and oftentimes you'll use these together, like you'll use an application gateway and then you'll have a load balancer as well. But again, if you need to filter traffic with more specifics, different attributes, or more of these HTTP ish attributes, then you would use something on the application layer, which would be the application gateway. But it's sort of the same concept. It's still meant to distribute or traffic. It just does it in a different way. I don't want to say better because again, it's case by case, right? So for example, here we have a website, our users access a website, and we have here an application gateway. And then it looks like we have a load balancer as well. And then it knows like, oh, depending which traffic to send to which way, right? If it needs to send images, it'll do that to the image server pool. If it needs to send video, it'll do it to the video server pool, right? But yeah, again, this networking is more so of like, oh, there's so many different things that you can add together that will best suit your need. Oh, looks like we're at the demo part. Okay, cool. I did try to keep the theory pretty short because I know Liam has something exciting to share with us. But just to recap what we've done already, episode 1, we already deployed the Bicep code. There was a GitHub repo that you can access those things. We had we don't necessarily have to go through. We had two VMs, 2 subnets, private, public, one there. I know we're using just a subsection of that today. And yes, this is what essentially we built in that session. And then in the third one, which was or I guess the second one, which was last session, we SSH'd into those machines, installed the Apache server. We modified some security group rules to filter traffic. And then we created a host web page, which we had that little Easter egg that was in the demo of last time. And today, we have step 4, which is securing your virtual network, and Liam is going to explain to us what's the demo about.
Thank you very much, Gwyn. Yes, so last week, you remember, we did Rickroll you, which is, I always love doing that. It's good fun. So today, we are taking a subset of the previous network, and we obviously, here we can see from the diagram pretty straight up, we've got a port 80, so the internet, essentially a TCP port 80, which is just HTTP. We're going to come through a public load balancer, which we've created, and that's going to distribute some traffic across a couple of virtual machines. So the first step that I'm going to do is run through some existing infrastructure that I've put in place for us, purely because it takes a lot of time to get through. I set everything up, essentially. It's a lot of point and click, a lot of boring stuff on sort of your behalf and my behalf. It's essentially just me and a portal, right? Clicking through a bunch of Azure things. You can do it from the CLI. You can do it many different ways, but it's good fun being visual. Step number 2, I'm then going to create 2 virtual machines on top of the existing infrastructure, and they're going to be within the WebTier subnet. So essentially what we're going to hit from the internet. From there, we're going to install Apache 2, like I did last time, and we're going to show the splash screen for Apache, which is like the default web page. Welcome to Apache. Here's your server. Then we're going to edit some of the home files. So the index.html, we're just going to change the title. One's going to be like VM number 1, and one's going to be VM number 2. And we can see that within our network, we've got 2 virtual machines with the same splash screen, which with a different title, essentially. From there, I'm going to get everybody on here to then bombard it with some traffic. And I don't know, that could be a mistake, but we'll see. I'm going to get you to hit the IP address, and we're going to see which one that you get. And it should see either VM number 1 or VM number 2. And if you keep reloading it, you'll essentially might see a bit of a flicker. And that's just how load balancing works. Now, before we move on, I actually want to touch on 2 things. I am not going to embarrass myself with the OSI model because it's been a while since I touched that one. But if you're unfamiliar with it, it is essentially a model which explains physical hardware right down from like your fiber wire or your fiber wires, your copper, right the way up to application layer, which I think is like layer 7 or the very top. So basically one on bottom and top, physical to your application, what you as a user interprets or plays with. So I also have just read a question: are load balancers hardware or software? Both. You can have them as both. So if you imagine like a whole bunch of servers, or a whole bunch of your PCs on your desk, and you plug them into a switch, that switch can be plugged into another server, which will then essentially act as a load balancer. It's this physical hardware, which can then distribute the traffic out again. On the flip side of that, you can also have software ones. So some servers allow you to do this. I know Nginx, you can have like a software load balancer. It runs at a different layer in the OSI model, purely because it's application. But it runs a little bit differently, but you can essentially have a software load balancer as well. So hopefully that answers your question. And the second thing that I want to touch on is something that Gwyn sort of mulled over a little bit. She went through the stateful and stateless of security groups, which I think was awesome. And that is a great way to explain it. So for context, stateful being sort of remembering things, and stateless is where you kind of don't remember things. So it doesn't really care. And I think actually, Gwyn, you may recall, I actually explained this to you when I think we were going through this like a month ago. And the analogy I used was like a passport control officer versus a like a door security man to a hotel or woman or whomever person. And essentially, an ACL is the access to your network, right? So it can be border force, it can be your sort of, I don't know, immigration at the airport, that gate where you go through. As long as you have a visa, you can come through that gate. And they say, yeah, okay, cool. You got the visa, you tick the box, and that can be TCP traffic. It can be UDP traffic. It can be, as long as you match the criteria for the network, it can let you in. Now, a security group by default blocks all incoming requests. So you have to set out allow rules. And that is what is called stateful, because it remembers things. So you're explicitly saying, allow only TCP traffic on this port with this IP address range. And that's essentially what it's doing. So once you got through border force, or once you got through, visa, immigration, you come into the country. or in this instance, you come into the network, and then you end up at your hotel. And this is where the security group comes. You've got to show that you've got a ticket to your hotel to say, hey, I can come into this hotel. I've booked a room. So the doorman says, yeah, cool. You've booked a room. You match our criteria. And then you're let in. However, somebody else or another packet, which is TCP traffic, port 80, but a different address range, who's matched the criteria to get into the network, might not necessarily match criteria to get into the hotel. So that's the kind of stateful, stateless sort of playoff that you're going to see with access control lists, firewalls versus security groups. It's kind of like a little bit more granular level. I think that's a really good way to remember it. And that's certainly how I do anyway. Okay, so where are we up to? What's the next slide, Gwen?
I think it's
Is that it?
Yeah, that's
Perfect.
Demo time.
Sure. So I will just get up my screen. So I'm just going to move you over to a different window over there. And do you have admin on StreamYard, Gwen? Can you pop it? There we go. Fantastic. Wonderful. So let's make sure it's big screen. Oh, it looks like I need to do an update on Chrome. So let me zoom in a little bit. Can we all see this? Yep, that looks good. Is that readable? Let's go down a little bit. Wonderful. Okay, so the first thing I want to do is run you through the network infrastructure that I've already set up. Now, inside here, I've got a resource group. Inside the resource group, I have got a virtual network, which I've called Liam VNet. Inside my virtual network, I have got a Bastion host, I have got a load balancer, and I've also got a NAT gateway. Now, a NAT gateway is a network address translation gateway. And what that allows me to do is talk from the inside of my network to the outside of my network without my virtual machines having any public IP addresses. And that's the important part here. I don't want anything to be seen from the outside. So if you remember, if you looked or watched or came to our last episode, I actually accessed a virtual machine from the internet. So I was able to type the IP address of my machine straight into the browser and hit it. I was also able to SSH into my virtual machine number 1 and SSH from there into virtual machine number 2 and play around. And it wasn't very secure. It wasn't good, right? So the whole point of this is locking it down to one IP address, i.e. the load balancer, that external traffic can hit. And then once it hits that, that traffic can then be distributed inside the network. But I'm not going to have anything publicly available from the virtual machine side. And this goes for databases. This can go for other infrastructure servers that you might want to be running. But in this instance, I am just going to have 2 virtual machines, and we're going to have a little bit of fun. We can also see in here that I have got a public IP address, and this is the IP address which is tethered essentially to the load balancer. And that load balancer is that sort of public facing one. And what else do we have in here? We have got the Bastion IP address, which is in a different subnet. And Bastion is another way to connect to the virtual machines. Now, when I create them, I'm not actually going to allow SSH port. The SSH port, I think it's 22. So I'm not going to be able to SSH from my machine into the virtual machine. Like, it's completely hidden. The only way I can do this is with admin rights through the portal with Bastion. And Bastion is just another really good way to jump in and manipulate the virtual machine or play with it, install packages, update things, you name it, you can do it with that. And it's all done through the portal and your web browser, but only if you have admin credentials. So let's jump into that, because I think I've been through everything here. Oh, of course, yeah, the Bastion has actually got an IP address associated with it as well, because if you want to be able to talk within a network, then you need to be able to see it, right? So in here, I'm just going to create a virtual machine. So it's a little bit of point and click, but I'm going to run through everything, what I'm doing and why in a moment. And because this is so big, I might get a little bit confused. So let's just move that one over to the side. Cool. So I'm going to select my virtual networking resource group, because that was where I just was. I am then going to give it a virtual machine. I'm going to give it a name. So I'm going to say, let's go VM1. I'm going to keep it in West Europe, because that is where all of my infrastructure is. I want it to be all within the same region. I could use UK South, but West Europe makes it a little bit more vague. It allows me to use a couple more areas. Now, last time I didn't select any availability options, and availability just means if something goes down, am I still able to connect to it from somewhere else. And I'm going to click availability zones. Now, an availability zone is essentially a physical data center. Let's say we choose the region UK South or West Europe. I don't know where this is, might be France or Germany or something like that. And essentially, it's going to say within that region, you're going to have a number of different data centers dotted around. Now, one could be in Frankfurt, one could be in Berlin, one could be, I don't know, anywhere else in Germany, essentially. But that's an availability zone. It's just a different data set. It's a physical data center somewhere else within the region. And for this virtual machine number 1, I'm just going to choose zone number 1. Security type is going to stay standard. I'm going to use a Ubuntu server because I like Linux. That's what I want. I'm not going to have a spot instance. Now, a spot instance means it's like a type of virtual machine that can be grabbed back at any point from Azure. It's kind of usually the cheapest one to use. And it just means that you're using free resources or freed up resources, could be any sort of size, but Azure have the right to take it back at any point. So we're not going to use a spot instance. I want this to stay up. I'm going to use a small size, this basic one, £6.53 a month. If you're watching from America, that's roughly about $8, maybe $9, not much at all, basically. Really small and not very costly. Authentication type, I'm going to use password. I'm going to use user and password. I'm going to say the username is Liam, and I'm going to put a password in, which I'm getting better at not speaking my mind when it comes to typing, because I do not want this to come out. Because it means that you all could then connect to this if you were jumping into this. So the public inbound ports is the other thing which I want to make a note about. Last time I allowed SSH, and you can have like HTTP, HTTPS, so different port numbers if you wanted to jump into the machine, but I don't. I want to put none. Now, I've done that deliberately because I'm going to do everything within Azure. I want this to be completely secret from the outside world. Next, I'm going to go to my disk, and this is where you could set up, big disk, your premium SSD. I could have standard H or hard disk drive, really, but I'm just going to leave it all. I don't really care about this. This doesn't matter for today. The one that does matter is networking. Now, I want to make sure that I'm in the right virtual network. So I'm in Liam VNet because that's the virtual network I have. I'm going to make sure that in my network, there is a subnet. Now, if I didn't have a subnet, then I'd just be able to create another one. But because I've sort of pre-created this network with one subnet, it's available to me. And you can see here, I've got another subnet for my Bastion instance, but that's just completely off limits. I can't touch that. That is a completely different IP address range. As you can see, it is 10.1.1.0 with a /27 subnet mask. That's another kettle of fish. It just means the amount of address or IP addresses that are available corresponding to the network. But I'm going to choose Liam backend subnet. Now, in a network, you need subnets for your virtual machines to sit and lie, and correspondingly to a load balancer, it needs to be able to direct traffic to a subnet or at least a virtual machine. So in this instance, we're going to put the virtual machine in this subnet. The other really good thing that I need to look at is IP address. I don't want this virtual machine to have a public IP address. Like I said, if you leave it as sort of standard like this, VM1-IP, it will create a public IP address for me, attach it to the machine, and essentially just render my security completely useless because, well, then you could hit it from the outside world. Albeit, you wouldn't have SSH port open, but I'm sure there is a number of ways you can still attack a network without having any SSH available to you. So we're going to put none. The next thing that I want to look at is my NIC network security group. So I'm going to click on advanced for this one, and I am not going to have it create one for me. As you can see there in brackets, it says new. I don't want Azure to create one for me. I want to play with it myself. Now, there isn't one selected, so I'm going to click create new. Now, this is where it gets a little bit more tricky to understand in a way, because this is where I'm going to be defining rules for my virtual machine, not the load balancer. So let me just call this, I don't know. Ooh, we do not want to do that. Let's scroll back over. Let's just call it Liam Network Security Group. And in here, I also want to add an inbound rule. Now, this inbound rule is going to be HTTP. So I want to allow HTTP traffic into this virtual machine, which means I can hit it from outside. Now, you can specify port ranges. Like I said, it can be, I don't know, a number of port. You have port ranges in TCP and UDP, which you can go and find out if you sort of Google them. There's lots of them. I'm just going to put a star. That just means everything. And the source can come from any one. Now, I can have service tags or IP addresses at this point. Like I said, this is kind of the granular level that you get down into with security groups. But I'm just going to put HTTP. That's port 80. It's TCP traffic. And I am going to allow everything that's on the above agenda. And the priority is the next thing I'm going to draw our attention to. With priority, the lower the number, the higher the priority. So I always want HTTP traffic to come through. I don't want anything to block it, nothing to come above it. So I'm going to put 100, and that's the lowest it can go. So if I hover over this, we can see here, they recommend to leave gaps, but you can see 100, 200, 300, and it's just so you don't have to add new rules without having overlaps or edit existing ones and things like that. But yeah, essentially, the lower the number, the higher the priority. So we're going to put 100. Ooh, my mouse is lagging a little bit there. Then I'm just going to say, let's just call this Liam Network Security Group, and Network Security Group, and I'm going to call it rule. Leave the description. We do not need that one. Now, you may be hidden on there because I've got this little box, but if I move that, you can see add that. And it has added a new security inbound rule to the security group for me. And the only other thing I have to do here is OK. Now, inside my network security group, you can see it's a new one. I've created it. It's got the rules I want. I am going to leave this box unchecked here, which is deleting the network interface card, I believe that's called, when the VM's deleted. Don't worry about that one, just leave that one. Because I've got a Linux, I'm essentially building a Linux box, I also don't have accelerated networking. It doesn't support it. I think that's only on the Windows ones. Doesn't matter. Again, I don't really care for that. But the one thing I do care about when I'm building this machine is load balancing. I've already created a load balancer. Now, I can stick this behind one straight away. And what this means is we have got Azure Load Balancer down here, which is what I've created. And I will talk a little bit about Application Gateway in a bit if we have time. But the Azure Load Balancer, and we can see here that the lovely screen is falling off the bottom. What for you? For me, it's falling off. There we go. So we can see Liam Load Balancer. That's what I've created. And that is essentially all I need to do. Click on that one. Come down, and I can see I have a backend pool available that I can put this virtual machine into. So it's already there. It's already pre-populated for me. Then I don't really care about anything else. I can just go ahead. I don't mind the management. I don't need to touch on management or tags or anything. I can just review and create. As you can see here, it's going to tell me that it's costing 0.0089 pence per hour. So really nothing. I think I'm like 89p. I don't even know what that equates to with the point. But yeah, different sizes, different virtual machines give you different prices. And that was it. So if I click on create, it's already validated. Dun, 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 dun. This might take a moment. But I'm going to whiz through this. Once this is done, I'm going to whiz through it and do it again for virtual machine number 2. I'm going to change 2 fundamental parts to virtual machine number 2. And that's going to basically be the 1, the name, and 2, the availability zone that I put it in. So this one was in zone number 1. Virtual machine number 2 is going to go into availability zone number 2, wherever that may be. I don't know. It's in Europe somewhere, in a different place. And thirdly, I am also going to select the security group that I have just created. So I want the same security group to apply to this virtual machine as well. So while we're waiting for this to come up, do we have any quick questions?
Yeah, we could probably... Did you do this one? Do you set up a NAT on your public load balancer to get out to the internet?
Yes, that is exactly what you do. Yeah, so a NAT gateway, so a network address translation gateway, just allows you to access the outside world from within, or vice versa, access your virtual machines through the load balancer. So it's that routing, that route table essentially is what we're building here. So when you create a request from your machine at home to the IP address of the load balancer, that request then doesn't get stuck at the load balancer. That then hits the network address translation gateway, or the other way around, it comes before it, and then it will feature it or filter it through to the virtual machines, allowing us to get to what's being hosted on there. So if there's a website, that then gets pumped out straight back out to the outside world, to yourself.
Cool.
And
Do you
this
want to do another
has,
one, or are you?
can do, yes, if we have more,
for the
we have
end
time.
if you want.
We have time, we can. Would you set up a stateful firewall on your internal VNets load balancer or just a public load balancer? That is a good question. I would set that only up on a public one. In fact, stateful firewall, that doesn't sound, no, stateless. Firewall is stateless. It just like allows or blocks based on certain criteria. But if it was a stateful, you'd do that internally because that's where you want the granular level of security. If that makes sense. I hope that makes sense.
That does make sense. Cool.
So I'm going to go ahead and create just one more virtual machine. Hopefully you can see that okay. So I just saw, can you zoom in a bit on the browser? I would love to, but it is super big already on my screen. Is that readable for you all? Just let me know. Hopefully that's okay.
It looks good to me. I'm looking at it in YouTube.
Cool. Alrighty. So again, I'm going to put this in the virtual networking resource group, which is where my virtual network is. I'm going to call this VM2. I'm going to again put it in West Europe. That's exactly where I want everything to be. The availability option, again, availability zone number 2. So I'm going to speed through this one a little bit quicker because there's no point boring you with this. Same. I'm going to click password. I'm going to have a user for Liam and set a password, which I try very hard not to say out loud. There we go. Again, I'm going to allow no ports to be opened or any inbound ports to be available. I'm going to click on straight through to networking. Again, it's going to be in the same VNet. So Liam VNet is going to be in the same backend subnet as the other virtual machine, and the IP address, same as before. I don't want one. I want this to be totally secret because I only want the load balancer to interact with this on the 10 dot network, which is an internal network for those of you who don't know. Usually if it's an external, it's like a 192 or I don't know, a 90 or something like that, 168 maybe. Again, depends on your port ranges, depends on your IP addresses, but 10 networks are more often than not internal networks. In fact, I think they're always internal networks. Again, so we're going to get at the network security group, going to click on advanced, and you can see here that we have an existing network security group, which I can just apply to this virtual machine. And again, I don't need to create another one. Same, got the same settings. Why create another one for the sake of creating one when we already have one that exists? I'm not going to delete the network interface card or when the virtual machine is deleted, leave that one unchecked, but I am going to have load balancing again, and I want to put it in the same one. We're going to use the Azure load balancer, so it's a public load balancer, if I didn't say that already. I'm going to use, the one that I've got, and I am going to stick it again into the backend pool that the load balancer is attached to. So when I created the load balancer, and I will actually go on and show you this if we have time at the end, the kind of logistics of building a load balancer and the kind of things you add into it, because I know I had to skip over that because of time. Cool. So I can look at management. Again, I don't really mind actually. I don't care about management. I don't care about the advanced tags. I just want to review and create. And again, it's going to tell me my price, same price before, because it's the same thing with a different name. In fact, you may get charged differently. That actually prompts me, depending on your SKU or where you're located. So this machine might cost more else in like a different, in a different region or a different availability zone, depending on what you've got set up. It may cost more. So yeah, that can differ. I lied. So again, I'm just going to go ahead and create it. So while this is running, this may take a second. If we have any questions, I can just take a question whilst this is deploying, because this is the worst bit about cloud and live demos.
Yeah, we got this one. Azure Firewall and Load Balancer SKUs seem to be based on features. Does this mean that performance ingress egress isn't a consideration?
That is a good question. So ingress egress, for those of you who do not know, that is the inbound and outbound connections that are coming in. So requests that come through a network. So if we roll that back a little bit, so Azure firewall and load balancer SKUs seem to be based on features. Yes, they are. And that is purely because the more you pay, the more you get, essentially. I don't think it really has an impact on the performance of the ingress and egress. I think that's pretty standard throughout the network. I haven't really done much research into that, but from what I've seen, and I use all different clouds ranging from Heroku, DigitalOcean, AWS, GCP, and Azure, it all seems to be pretty standard across all clouds from that sense.
Yeah, just to add to this, I know like Firewall Premium has like TLS inspection. I think it's like URL filtering versus like the standard one doesn't. And it's more so, it's not like one can handle more traffic than the other. It's like if you need more features, and obviously one is going to be more expensive than the other.
Yeah, of course. It's just like with every security feature that you want. So you could have like Windows Defender or Azure Defender, things like that bolted on. Extra cost means more security, means you kind of get the logistics of that. And again, they help prevent certain things. So if you're thinking about a load balancer, you want DDoS protection. I didn't actually set that up on this one, which means that anybody can bombard my load balancer. But essentially, if you don't know what DDoS is, it's distributed denial of service. And that's when loads of like requests come into one sort of port or one service and basically overwhelm it. And it says, hey, I can't do this anymore, and shuts itself down. That's essentially what a DDoS is. And there's a way to protect against it, but it costs more money for these sort of things if you want to be bolting them on. I think in Azure it's free, but I know in other clouds it's not. Wonderful. So let's actually have a look at what we've deployed. So let's look at, I'm not going to go to this, I'm going to go to virtual machines. And we can see here that I have got two virtual machines, VM1 and VM number 2. And they're both started up, they're running. As you can see, we've got the IP address. Now, I hope this is the same on the other one. Otherwise, ignore everything I've said until now. So this is 20.86.211.161. Now, if I go back to virtual machines, we can see that that's exactly the same public IP address. And that is because I'm using a front-end IP address from the load balancer. That load balancer is the kingpin in this whole network now, because that's the only point of access for these virtual machines. If I try to go to the IP address, absolutely nothing will happen because these virtual machines are essentially just like dead Linux boxes. Well, not dead, they're alive, but they're not doing anything. So this is where Bastion comes in. So if I want to connect to any of these virtual machines, let's just start from number 1, because let's just go in order. If I click on connect, I have a number of different ways to do this. Again, it's just saying, to improve your security, enable just-in-time access on this VM. I'm not going to bother with that one, but essentially this is where you start getting prompts for security. So we have this lovely tab called Bastion, and I want to click on use Bastion. And what I'm going to do, what it is essentially allowing me to jump into my virtual machine from the credentials that I've just set up. So if I say Liam, and then I put in my password and click connect, hopefully my pop-up blocker doesn't block this, so let's allow that. Network connection. There we go. We are into our virtual machine. Now, I appreciate that might be quite small, so I don't even know if I can zoom in. It's a little bit. Nope, my keyboard. This is just a terminal in there. I have no idea how you zoom. Let's go zoom in. The
browser. Oh no.
Yeah, it doesn't actually like. Oh, there you go, everybody. Wow. That is a feature request to the Azure Bastion team straight from this stream. But if we can see, if I start typing. Just like I did last time, I've got into my virtual machine, but I wouldn't be able to do this from my own terminal on my PC. So what I want to do is I'm going to install Apache. So I'm just going to copy and paste a command because, stream life. There we go. Sudo apt get install Apache 2. And I'm just going to say the -y just means yes to any prompts that it asks for. So I don't need to sort of type extra things when it says, do you want to really install this? So I just say, yeah, go for it. Give that a moment to set up. I'm going to do this on both virtual machines. It doesn't take long. It takes a couple of seconds. And from a previous stream, we can already know that it runs straight away. This automatically starts the server for me. So there we go. That's done. Now, if I go, I'm going to do a sudo vi, so just a terminal editor. And I know where this path is because I've done this a few times. It's going to var, it's going to be in www, it's going to be in HTML, and the index.html is what I want to edit. So I can go into here and edit this one. So let's scroll all the way down. This is good fun. I don't like this editor. I really don't. But hey, it's good for the purpose it provides. Okay, here we go. So let's just go and delete this. So let's go insert and let's just get to the end and type in one more. VM, this is VM number 1. Here it is. And let's exit and right and quit that one, exit the file and save it. Cool. So I can now get out of there and it will close the window for me so I can disconnect, close that one. I now want to go and do the exact same thing on virtual machine number 2. So again, let's go into connect. I'm going to click on Bastion. Same, because I am super secure. I use the same thing for both virtual machines. Oh, but I've got clunky fingers. Yeah. I almost said it then. There we go. Right, so we're in again. Cool. And same again, I'm just going to install Apache 2. And give it a moment to update and do its thing. So usually when you have virtual machines, you do want to do an update, like an apt-get update or whatever it is in your Linux distribution that you're running, maybe whether it's apt or whether it's yum. You want to do the same thing, but I've not bothered. We're just going cold turkey with this one and just hoping it works. So again, I want to do a sudo vi, jump straight back into that file that I was in. Find the heading. Actually, the good thing about this editor is if I do a sudo vi straight back on the other file on the other virtual machine, it knows where I left off, which is pretty cool. I'd call that stateful. My jokes are bad. My jokes are bad. But hey, we rock and roll. So let's do the same thing. This is virtual machine number 2. And let's exit this one. We're going to write and quit, and that will save it. Jump out. Now, here's the magic, or less magic, more so logic. We are going to go to the public IP address. Because it's the same thing on each of these machines, we can just copy it to Dash or clipboard, and hopefully, I really hope this works. VM number 2, as you can see here, we have a title that says VM2. If I just reload this a whole bunch of times, straight away, I've gone to VM number 1. But quick. If I just, that's just the load balance. If I smash this a load of times, I hope maybe somebody else can do this, but it should go to different virtual machine. And I don't know why it's not doing it.
Just do it a couple more times.
Maybe everybody else can. It takes a while, doesn't it?
What's the IP?
It is 20.86.
Yep.
.211.161.
I already got them too.
Fantastic. I don't know. This doesn't want to go to VM2 for me. Maybe it needs more traffic. But essentially what's happening is that load balancer is taking all these requests in. By the way, anybody on the stream, feel free to plug this in, this IP address in, and give it a go. So I think we also have like another example of this in a different network, which was working a little bit better earlier. Oh, there we go. We got virtual machine number 2 on my one as well. So you can see that I'm essentially hitting the same endpoint time and time again, but the traffic is being distributed differently across different virtual machines. Now, this is really good in production because in production, you're going to have a server. You're probably going to have one server, and that one server is going to accumulate or like take all the traffic in. However, you see one server. On the back end, this is perfect for scaling. Now, this load balancer, which I created, if I go and try and create another one, now, if I click on here, like I said earlier, let's just go around, stick in same one, give it demo load balancer name, Western Europe, all this stuff. We can look at the IP configuration, and I don't know if it's actually going to be in here. It might be in a different one, actually. Let's just go to a front end. Let's choose an event just for the sake. Oh, I can't do it. Okay, so basically in here, we have the option to scale. And what's going to happen is when loads of traffic comes in and there's not enough virtual machines on the back end, the load balancer can take all this traffic and say, there's loads of traffic. Where do I send it? We've only got one virtual machine. Well, actually, it can determine when to scale and how to scale, whether it's horizontal scaling, where you just like add loads of more of the same machine. And it can determine how to do that. So it deals with peaks and troughs really well. And this is essentially how production networks work, basically. You can imagine a shop that has maybe a sale on a Friday night, has got loads of traffic for the weekend, right, for that sale. But on a Monday, that's not going to have as much traffic as on the Friday. So there you've got a peak and a trough. And you can scale out and scale in. It's all about being elastic and the elasticity of cloud. And that kind of wraps up today's demo, showing how a load balancer really works. And I guess I can kind of show you the kind of ins and outs of what's going on. So a front-end IP is that IP address that I created. It's public, associated with the load balancer. The backend pool, which has some virtual machines in it, which I added, that previously was empty. We have a health probe, which basically says, are these machines up? This is poking on port 80. Is the machines up? Is the load balancer up? Are you alive, basically? And if you're not, it will do a retry. And if it gets to the end of the retries and hasn't found a response, then it will just throw an error and say, hey, something's wrong. And that will throw an alert in your network. So this is kind of how you are working inside a fully functional network to help diagnose things and help prevent errors, essentially. And yeah, I guess that kind of wraps up nicely with this demo. So I think we've got a couple minutes left. We will steam through the slides, what's left, and
let me
talk about, let Gwen take this one away. I will filter through and have a look for some questions.
Pull up the share screen. Yeah, there's a couple good questions that we can get to. Just want to share the rest of the slides we have here. All right, cool. Episode recap. Covered a couple of things. What is network security? How do we the options we have to a couple of options we have to secure a virtual network. Network access control lists versus security groups, and then load balancing. And then don't forget, you have I shared the link earlier, the Cloud Skills Challenge, but just about 400 people, which I think is insane. And still plenty of vouchers to give away. I know someone told me to check my Twitter. You had reached out to me. Liam and I are actually going to go through a couple of messages today. Make sure we get the vouchers to the people who have actually completed them. So we'll take a look. But the Cloud Skills Challenge has a bunch of like different modules covering topics that we've done in the series. And then you get 100% off the AZ700 certification if you are within the first 50 people to reach out to us who have completed it. So yeah, keep that in mind. Just connect with us on Twitter or LinkedIn, and our Twitter's on the bottom left. And you got to share a screenshot of your MS Learn profile link, and then of that you've actually completed it. Share that with us. Again, the link to the Cloud Skills Challenge is right here, aka.ms/Azure VNets CSC2. And cool. And that is it for us. We're going to start answering questions, but you can find us. Those are Liam's links, Twitter, LinkedIn, GitHub, and then my links are also here too. But I'll keep this. We'll keep this one on maybe, and then we could just answer some questions.
Leave that one up.
Let's see.
Cool. So I actually had a little run through the questions whilst Gwen was speaking, and Kevin Oliver said, you can run commands like this when you create the machine, right? You are 100% correct. So using Bastion, it's just hopping into the virtual machine and using that terminal inside. It's just a way to connect with it, just like you would SSH into a machine from your machine, or if you're using Putty or like another different application that allows you to jump into them. So yes, 100% correct. You can use commands like that. Now, that doesn't scare or get away from the fact that if the virtual machine is a Linux box, you use Linux commands with the correct package manager, like I said, apt or yum, depending on distribution, things like that. And if you're Windows, then of course you'll be using PowerShell. Hopefully that answers that question. If you shut down what if you shut down one virtual machine? If you shut down one virtual machine, nothing happens. It would just direct straight to the other one. That's the beauty of a load balancer. It knows that it's down. It will tell me that it's down with the health probe and say, hey, this one's not up. It is shut down. Much like containers, if you're familiar with Kubernetes, has a health probe. It's just Kubernetes is essentially networking, but without the virtual machines, but containers. Very similar. And I guess that kind of answers the following question. Why would you use this approach instead of using load balancer and autoscalers built into app service web apps and Kubernetes? And thank you, Kevin, because I believe you also answered that one for me by saying, yes, if your application does not run or isn't compatible with Kubernetes, if you don't want to run a microservice infrastructure, bear in mind that the day and age we're in at the moment, the containers ecosystem is very much fairly new companies. It's startup era, medium-sized companies, and that's kind of what's been going on through the sort of the 2010s. Prior to that, everybody, most companies and infrastructure has been virtual machines. You know, it's just the way that it is in terms of corporate world. Mm-hmm. I speak to so many people from different companies who are using like real legacy systems, because if you think about old companies, let's talk about Microsoft for 5 seconds. Microsoft's got a lot of infrastructure, which is on-prem. It's got a lot of infrastructure in the cloud. A lot of virtual machines run a lot of infrastructure for us. The same as other companies, whereas a smaller company might be using containers or a microservice, like a very fluid network, purely because they don't have the technical debts that the other older, bigger companies might have, if that makes sense.
I think that's it.
Yeah, I think that is all the questions.
We're at time.
It has been, bang on. Been fantastic. Thank you ever so much, everybody. And I hope you learned something. I certainly have.
Yep. Thank you, everyone. Reach out to us on LinkedIn or Twitter once you complete that challenge. There's still plenty of vouchers to give away, so hop on that. And hope you learned something.
Alrighty. Thank you.
Thank you.
Goodbye, everyone.